do last time? Well, we spoke about where the middle or the center of the data is, and we found things called the mean, the mode, and the median. And of those, and the median, we gave this interesting name called Q2, or the second quartile. And what we did was when we found the median, we first calculated its position by using this formula, where n is the number of items in the data set. And then once we found its position, we then could find the value of Q2. What else was a bit special about the median? Can anybody remember something different, or like it felt like this was chop chop, but the median was a little bit special in some ways? Who can give me a little bit of feedback about what they remember about the median being a bit special? It requires a bit of extra work. Lumelo, exactly. So you need to rank or arrange the data from smallest to biggest. And if you haven't done that, then you won't get the median correctly, because when you calculate the positions won't be set up properly. The other thing we say about the median is the median is not as affected by something called outliers. So when you collect data in the real world, sometimes human error happen. And if your data set, if you're measuring where the middle is and you use the mean, you're much more affected by if a dodgy value sneaks into your data set. Whereas the median, because it's about the order of things, we say it's a more robust statistic. That's like a fancy way of saying it holds together well in the real world conditions a bit better. Okay. Lorette, you're absolutely correct. The median sometimes falls between two numbers. So let's say if we had we were counting and we had position, whatever it is, and we found that the median falls in the position between these two, then what we do is we average out to find the value. Okay. Great. You guys are doing awesome. So what is today's lesson about? So today's lesson is really about, if we've got a data set, how do we figure out how spread out it is? Okay. So, and then things that we're going to talk about are the range, which is the simplest measure of dispersion or measure of spread. We're going to talk about something called the interquartile range, which is really just measuring where does the middle 50% of data sit in a data set. In order to find the interquartile range, you first have to find the quartiles. If there's time, we may talk about percentiles, which are quite closely related to quartiles. And then we will definitely spend some time talking about the standard deviation in the second half of the lesson. Okay, so that is the overview. Today is all about how do we tell how spread out a data set is. So we're going to start with this one, which I actually was doing at the end of the last lesson, but there may be some of you who are who weren't here. So let's just pull up what I wrote in the last lesson. And what I did in the last lesson is I first worked out the position of Q1. And the way I did that was I used the formula a quarter times n plus 1. And there were 10 items in the data set. If I count them, I can see 10. And that gives me the 2.75th position, which means basically Q1 is sitting here. Then I found the median using this calculation. It's the 5.5th calculation. And so that is 3, 4, 5. The median, or Q2, is here. And then for Q3, it was in the 8.25th position. That's 6, 7, 8. And here is Q3. Now, what these things do is they basically divide the data up into quarters. And so this patch here, the middle 50%, is called the interquartile range. And you find it by going Q3 minus Q1. So I want you to find me, using on the board, what is the interquartile range for this data set. And it might be that some of you are a bit unsure. And And that's fine. You can ask questions, but I will just highlight what Q3 is and what Q1 is based on the calculations we did last time. So what is my interquartile range going to be? So we need to find what Q3 is, and Q3 was 22 minus Q1, which is 12.5. And we should get 9.5. So what that means is that the middle 50% of the data is sitting within 9.5 units. Okay, no problem. So we will practice that going forward today. But there is another measure of spread, which is the range. Can you tell me what the range is for this data set? Can you tell me what the range is for this data set? So range is normally max minus min. So can you find that? And I guess that the range, all the data sits within 21 units. Okay, so we've covered what the range is. I think you all probably knew. The interquartile range is a bit new. There's also something called semi-interquartile range. Okay, so semi-interquartile range. And all that is whatever the interquartile range is divided by 2. So what we think the interquartile range is, the semi-interquartile range is for this data set. What do we think my semi-interquartile range is? It should just be 9.5 divided by 2, which is 4.75. Okay, so we have 3 ways of measuring how spread out the data is. To find the interquartile range, you actually only have to find Q3 and Q1. I didn't even need to find the median, but it's good to know how to do it just in case. Give me a thumbs up if you're following what I'm doing generally okay and are ready for another example. Give me a thumbs down if you're feeling a bit unsure or lost, or maybe you just want to ask a question, that is available to you. Okay. Well then, let us not wait any longer. Let us give you another example. So here is another data set. And what I'm going to tell you is how many items are in this data set. So N is 22 items. I want you to find me the range, the interquartile range, and the semi-interquartile range for this data set. And what I will say is, in order to do that, you are going to have to find what Q3 and Q1 is. And since we are still getting going with this, I'll give you the hint that you first need to calculate the position of these things. And for that, this formula is helpful. Okay, over to you guys. If you're unsure, I would love you to ask a question or make a comment in the chat. I'll be watching that. But over to you. Be the best you can be. Okay, I see answers. What does interquartile mean? So Impol, interquartile just means between the 2 quartiles. So interquartile range is just the distance between Q3 minus Q1. And so we often say it's the middle 50% of the data, because it's literally between 3/4 of the way through the data and 25% of the way through the data. So that answers your question, Paul. So the range is definitely 21. It's just 30 minus 9. So 21. So this, I need to first find the positions. Maybe my calculator.
Yes, please.
Cool. So 70.25th, and then what is the other one going to be? Okay, 5.75 position. And let's find those. So 1, 2, 3, 6. So it's going to be Q1 is going to be there. Where's Q3? 17. So it feels to me like Q3 should be there. And that means that Q1 will just be 12 plus 15 over 2, which is 13.5. And Q3 should be just 26.5. Let me see in the chat. A lot of people are saying 11 or 11.5. Let's see what I get for my interquartile range. So I get 26.5 minus 13.5, which is 13 for me. So I get 13 for my interquartile range. And what that means is that the middle 50% of the data is sitting within 13 units of spread. It's, that's the middle 50%. What is the semi-interquartile range going to be? So it has to be whatever the interquartile range was, but just divided by 2. And so 13 divided by 2 should be 6.5 units. Yeah, or 6.5, yeah. So give me a thumbs up if you're feeling like you're generally following. Give me a thumbs down if you're feeling a bit uncertain. I'd love a question if there's something I can clarify. I know that the position calculations take some time to kind of get into, and I think another example will help us. We're going to keep doing this, but I just want to get a quick class mood check. Okay, so there's still quite a few students who need to practice this a bit more, and that's fine. We're going to do another example now. So how about we do this one? Here is a set of data. I want you to only find me the interquartile range of the range. Michaela's asked, so wouldn't Q1 be in the middle of the first half? Yes, it would be in the middle of the first half. So 5.1, 2, 3, 4, 5, 2, 3, 6. Yes, it would be. Exactly. So it's halfway between there. Yeah, so that's fine. Oh, okay. So Michaela, there are some other ways. There is some variance. Okay, so if you're counting it manually, but this way I think is the most reliable to use generally. Okay. Okay, let's just, what is n for this thing here? 1, 2, 3, 4, 5, 6, 7. So n is 7. What is the range and interquartile range for this data set? So Michaela, I do take what you're saying that there are 2 interpretations of what Q1 could be, but I would say stick to this position formula generally, because it works pretty much in all situations, and both are correct in the case that you're raising. Okay, so range is max minus min. So you get 29 minus 12, and that's 17. Now, in order to find, let's start with the position. because I know I need to do this. Now, what was my n again? My n was 7. So it feels to me like this should just be 2, like the second position, and this should be the 6th position. So that's quite nice, because this time it didn't fall between values, it fell exactly on a value. So if I count from the beginning, the 2nd position is 13, and the 6th position is there. So now I know that this is 13 and this is 27. And so my interquartile range is just going to be 14. Okay, so take a moment to look at that, see if you have any questions or comments, or the interquartile range is something that's important for the box and whisker plots we're going to cover in the next lesson. And also it's a very common way of comparing two data sets. So if the interquartile range is smaller in one data set than the other, it generally tells us that that data set is less spread out than the other one. And so today is all about being spread out. So we'll do that. Okay, let's do another one before the break. Let's do this one. What is the interquartile range for the following set of numbers? I'll help you by helping you count what n is. 1, 2, 3, 20. Okay, n is equal to 20. So there are 20 items in the data set. Do your best there to tell me what you think the IQR is. Okay, so so we get So what do we get? That is the question. Pop your answer in the chat, the one that you think is correct. I've indicated visually on the screen where I think Q1 is and where Q3 is. And the interquartile range is going to be between these two, huh? That's where the middle 50% is sitting. So because it falls between two numbers, I think this one has to be, 9 plus 11, yep. So 9 plus 11 over 2, that gives me 10 for Q1, or the lower quartile. And Q3 is going to be 31 plus 33 over 2, which is 32. But now that still doesn't give us the interquartile range. The interquartile range is going to be that one. So I think it is B, 22. So it definitely feels like doing the position calculation properly at the beginning, knowing what the number of items is, and then sort of mechanically going through these processes makes this a lot easier once you get all those processes. So yeah, I think we can still squeeze in actually a little bit more before halftime. So if there are any questions, just raise your hand or put them in the chat. Otherwise, we're going to squeeze in some more questions before halftime. Okay, well, how about this? Find the lower quartile of the following set of schools. Tell me which option you think is correct. Oh, sorry. Now, this time I'm only asking for the lower quartile, so I don't have to do as much work. So I must make sure for the lower quartile, I always have a quarter in front, but I do need to know what n is. Luckily, it's a small data set, 4, 5, 6, 7. So this is 7 plus 1. So this is in the second position. And so what is Q1? Position 2 is going to be 7. And so 7 is the answer. Okay, awesome. And I see in the chat, 7 is a very popular number. Kayleen's asked, what is the range? The range, if the data is ranked from smallest to biggest, yes, then it will be the last one. But generally, we'd say the range is the maximum value in the data set minus the minimum value. So the biggest value is 15, the smallest value is 6. So that would be the range for this data set. It's not the question that's asked, but Kayleen's asked in the chat. Now, if the data wasn't arranged from smallest to biggest, then it's not always the first and the last, though. Not that one. I want to know that one. Find the upper quartile or Q3 for this one. Find the upper quartile for this one. Pleasure, Kelly. Now, one of the sneaky things I've noticed is they have been a bit tricky. Why have they been a bit tricky with this question? I feel like I've thrown a curveball in. And the reason I know I've thrown a curveball in is I can see the answers are all coming in different. So who would like to tell me what they've noticed in this question? Aha, Okanele and Pamelo, it's not ranked. When you find, when you're trying to find the, oh, something just popped up my screen without me wanting to be there. So, okay, it's gone away. What you need to do to find the upper quartile, the data needs to be ranked from smallest to biggest before you do position calculation. So you have to first 119, then 12. So let's make sure. I like crossing out so I don't forget. 136, 140, 150, 150. So that is the order I really want. I can see that there are 6 items, and now I can begin doing the position calculation, and then after that, I will find what Q3 is. So we have 3/4 times n plus 1. What do we think the answer is going to be now? What are we going to have? I'm going to have 7. No, we're going to have 6. That's 6 plus 1. Which then gives us 3/4 times 7 in your calculator. You should get 5.25. So let's go and find where that is. 1, 2, 3, 4, 5. Oh, but it's between these two, which means that the average of 150 and 150, the correct answer should be 150. Issa Mayeni, do you want to unmute yourself and we can, or can we unmute and then we'll have a conversation?
Yes. Hi, sir.
Hey, how's it going?
I'm good, and you, sir?
Very good. What can I do for you?
So in the brackets, you wrote there 6 plus 1. If I wrote there 7, then would I still get the same answer, or would it be different?
It will give you the same because the bracket's always done first. So if you, okay, well, hold on, wait. N is always going to be the number of items. So if you go 3/4 times 7, there's no problem. You'll still get 5.25. Does that make sense? Yeah, there's no problem with that.
Yeah.
Cool.
Okay, thank you.
All right. Pleasure. We've done a lot. It's now time for a break. So I want everybody turn the cameras on. I want you to stand up with me, and I want you to just take a moment to unwind. And my eyes are feeling a bit like they need a break. So let's stand up. Let's start by just stretching our necks. Okay. And then stretch to the other side. Okay. Okay. And then let's just swing our arms a bit to loosen up any tension in the shoulders. Stand with your feet apart. Nice relaxed posture. And just swing your arms. Take some nice deep breaths. And then you can start turning a little bit. Just a little bit when you first start. And then as you relax, you should feel your hips able to turn a bit more. You can turn around a bit more. Okay, then let's roll our shoulders back. And while we're rolling our shoulders back, we're looking away into the distance so our eyes can unwind and relax. Just keep something in focus, which is far away. And then you can change the direction of rolling your shoulders, and you can look to another point on the opposite side of the room. And hopefully your eyes are starting to feel a little bit less tight. Let's do a tricep stretch. Okay. And just look up in front of you. You should feel a bit of burn in your tricep. And then you can switch. Actually, I'm feeling some tightness in my stomach muscles too. But I think that's all part of it. And then I want to do something called a pen flip. This was requested in the last lesson. So I want you to grab a pen. A marker would be better, but any sort of pen. And what you're going to try and do is you're going to try and toss it in the air. You're holding at the bottom, and I want it to only spin once, and you catch it on the same end. So the whole thing is the control you need to only have it flip over once. It is easier with heavier items. So go grab an item quickly. I'd love to see you doing this. This is a lot of fun. So turn your cameras on if you can. And then you grab an item, hold it, and you just go, oh, that was too much. So hold it. Didn't get it right that time. That was better. That was about right. And what this does is it forces you to focus on something, and that gives your brain a break. And if you're really feeling ninja, you try your non-dominant hand. You go like this. Oh, I'm rubbish. Well, clearly I need a bit of practice. Okay, it's a great thing to do if you want to unwind when you're been studying too much and you just want to take a break. Okay, so that's, and then let's just do some air skipping to just get our hearts pumping. We'll do 20 in 3, 2, 1. Let's go. And I do hope that you are feeling like your brain has had a break. Let's just do one little puzzle before I, why is my screen going crazy? Here is your brain break for today. What is a triangle worth in this context? And you can let me know in the chat what you think is the answer. What do you think the answer is going to be? Feels like schools are fairly forgiving. It feels to me like the circles should be 5 and 5. Because 5 plus 5 must be 10, so they're all my circles. And Ismayeni has said 2. Do I agree with you? 5 times 2 is 10. 10 plus 2 is 12. So I'm on your team there. Now, what is the triangle going to be worth then? Because I need, remember, BODMAS says that this must get done and this must also get done. And then, so 5, so that's 10. 10 minus something is 5, and then the only way this could be 5 is if the triangle was, Kennedy and John, I agree. It must be 1, because we get 10 minus 5, and so a triangle is 1, and Okukle also agrees. Okay, fantastic. Lerato and Nkosi also agrees. So we are in agreement. A triangle is worth 1. Okay, so let us return to our lesson about how spread out data is. And what I want to do in the second part of the lesson is I want to talk about something called the standard deviation. Now, we're mainly going to use our calculators to do this, but I will explain briefly what the standard deviation is and what it measures. So this is the fancy formula for the standard deviation. I often think of it looking like an apple, like an apple with a little bit of a sort of core thing sticking out. And what it measures is how far away on average something is from the mean or from the middle. So what this formula is saying is take a data point and then subtract the mean. So the mean is, in this case, is u. Then take those differences. So maybe I'll even lay it out in a table, show you what's going on. So if you imagine all the items in a data set being written, then if you get the mean of a data set, that thing will be u. So let me give you an example. Let's say that this is 13, and some of my data sets are like 16, 17, 19, 18. These are data points. If I wanted to know what this is, I would just go 16 minus 13, so that would be 3. 17 minus 13 would be 4. 19 minus 13 would be 6. 18 minus 13 would be 5. Now, that isn't the standard deviation. That's not what your calculator does yet. Your calculator does more stuff. It takes this thing and it squares it. So what it's doing is it's taking the distance from the mean and it's squaring it. Now, what would that look like? Well, the distance from the mean was 3. So what is that squared? Let me use a different color for effect. It's going to be 9. 4 squared is 16. 6 squared is 36. And 5 squared is 25. Now, what this has done is this is the difference. This is the difference squared. But that's not done yet. So let me just do a quick check-in. Thumbs up if you followed what I've done so far. You don't have to understand everything, but like Do you see how I'm trying to explain what's going on in here? Okay. Now, in mathematics, there's this lovely symbol that looks like a Greek letter. What does it mean in mathematics for sigma to be invoked? Who would like to tell me? Estimated, almost. Sigma means to sum up. So we are going to sum up all the squared differences. And so if you imagine summing up, what are we going to get if we sum up all of these values? Maybe you can help me. I'm going to try with the calculator first. 9 plus 16 plus 36 plus 25. Okay. Now, the sum here would give me 86. Now, Kayleen, I'm doing this quickly to show you the manual process, but in reality, we're going to use our calculators. I'm just explaining what the calculator is doing. Okay, so far, what have we done? We've got a sum of 86. Now, if we look at this formula, we now have to divide by n. What do you think n is going to be in this scenario? What do you think n is going to be? So n is the number of items in the data set, and n is going to be 4. Yes, exactly. So we go divided by 4. And so now your calculator would have done this automatically, but I'm going to go to my calculator and go square root 86 divided by 4, and I get 4.64. So my standard deviation, or SD, or the symbol looks like that, would be 4.64 if I round off. And all this is telling me is it's telling me how spread out the data is, how far away is it from the mean on average. And it turns out that's a very helpful thing. I've probably done a bit more detail than I normally would do, but I wanted to do it with the standard class. But in reality, most of the time we use the calculator to help us. So let's bring the calculator up to the screen. And Kia, can you just confirm that you can see what is going on? You can see the calculator.
And the calculator was on, but now it's off. Okay, now it's back again.
Oh, wait. Now it's again. Okay. We're playing cat and mouse. I think the calculator should be back. Are you seeing a calculator?
Yes, 100%.
Okay, so let me show you how this is typically done in a past exam question, right? If you imagine, if I was doing it with a table, this would take a long time. So what we do instead is we use the calculator. So how do you find the mean and standard deviation? I think, Cass, you were asking me in the last lesson, how do you find the mean using the calculator? You can do it the way that I'm going to show you now, but most important step, get your calculators out, have them on standby, and click the mode button. Then hit mode, and then with stat, hit 2. So maybe I can even write the things down for you over here. So you go mode, then you hit stat, and then you hit 2. Let's see that I did that. So mode, let me clear. So mode 2, so actually the stat button was the number 2. Then what I have to do is I have to hit var and 1. And you get that look, which is basically where you put your data in. Give me a thumbs up if you're with me so far. Give me a thumbs down if you're not with me. Okay, so now I want to put my data in, and this is kind of the boring part, but it's better than doing it manually yourself. So 356 equals, I want you to do this with me, and I'm just going row by row like this. Okay, now at this point, I've got 12 data items, and that makes me happy because if I look at the table, I have 4 by 3. So 12 is a good number. For those who've got left behind, don't worry, we're going to do this more than once, but basically at this point, you input the data. And all I was doing was I was literally going down this column and going equals. Now, if you are not in the stat mode, then life will be difficult for you. So you have to do that first. If you're really struggling, you might want to reset your calculator if your calculator is being completely uncooperative. But what is the next step? Now, the next step after inputting data is to hit the AC key. So you hit AC and you have a moment where you go, oh, I hope I haven't lost my data. You haven't, don't worry, I will do that to you. But you do have to go and find it somewhere. So where are we going to find it? Well, we are going to find it by going Shift. So that's this button over here, Shift, and then 1. So Shift, and then 1. And then after I've hit 1, I need to choose 4 for the var. So it is 4 and var. And then I get this menu. Now, which one here reminds you of the standard deviation I spoke about earlier? Which one do you think it is? Do you think it's 1, 2, 3, or 4? It's going to be 3, the one that looks a bit like an apple, hey? So you go 3. So let me put that down here. You get 3. And if I hit 3, I then have to hit equals. And I then should get, let me go back to my pen. I should get a value of 220.20. And what that's saying, the symbol looks like that, is the standard deviation for this data set is 220. So on average, a value is 220 units away from the mean. But we don't actually, so that's step 1. But now we don't actually know what the mean is. So now I'm going to show you how you can get the mean at the same time. And often the mean is just adding up the items and dividing by them. But there's a quicker way here. And so for those who, okay, Kayleen got something very, very close. There might have been a typo, Kayleen, in your input. Don't worry, we're going to do another one before the lesson ends. But before I do that, I want to show you how you can get the mean of this data set at the same time. So I'm going to hit AC again. I'm going to hit Shift 1. And then I get into this menu and I hit 4 for var. And for var, I don't know if anyone's a soccer fan. There's a soccer player called Jamie Varney, so you can think of var. And now I'm not going to choose 3. I want to choose 2. Because 2 is the mean. So I hit 2, and you should get for the mean 501. And so what that's saying is this data set. The middle of the data set, or the mean of the data set, is 501. And on average, the items are 200 units away from the mean on average. So the average distance from the mean is about 220. So in that direction and that direction. So one standard deviation in that direction would get you up to, so what would that be? You add 220, so it would be 721.20. That would be one standard deviation up. And then one standard deviation down would be 501 minus 220.20, and that would be 280.8. So that would be one standard deviation within the mean. Like those, that's how many, often questions ask about how many values are within one standard deviation of the mean. Well, the upper bound of one standard deviation above the mean is 721. One standard deviation below the mean is that. Okay, now I think the way to do this is to practice. And so what I'm going to do is I'm going to give you another question. And let's start by finding the standard deviation of this multiple choice question with this data set. you don't have to put the data in order for the standard deviation, and see if you can choose for me the correct option. So in Paul, I want to, in this question, find the standard deviation. To do that, I'm going to click mode, and then 2, and then 1. And then I should get that. So that is the first 3 steps, is to go mode, stat, var. And now I'm ready to input data. For those who are struggling with their calculators, give me let me know in the chat if I can help you. But now I have to actually do the hard work of putting the data in. So I go 5 equals 10 equals 7 equals 12. 20, 15 equals 22. Okay, so that's what I call the inputting of the data. Now I hit AC, which just clears. And now I have to go and find my data again. So I go Shift 1. So I've done that. Shift 1. I hit 4 for Varney or VAR. It's not really Varney, it's for variance, but hopefully that name sticks in your head. So that is that. And then I hit 3 for the standard deviation and then equals. And so which option do we think is correct? I'm getting 6.89, which means that option is correct. Now, as a bonus question, I want you to find me the mean for this data set. And I don't want you to do it by adding everything up and dividing. I want you to use the calculator function that I just showed you. And you start by going AC, Shift 1. And then what do you think I have to do next? To go find the mean. So I have to hit 4. But now I can't hit 3 anymore. I'm going to hit 2. And I go equals, and the mean should be 10.1. Okay. Now, bonus question to end today. How many values are within one standard deviation of the mean? So my question is, for the current data set, how many values are within one standard deviation of the mean? And what I'll say is this, I'll say that you need the upper bound and you need the lower bound. And the way you do that is you take mean and you subtract the standard deviation. And then for this one, you say, take the mean and add the standard deviation. How many values fall within this range? So the upper, Flamelo, is 16.99. That looks good to me, Flamelo. What about the lower bound? 10.1 minus 6.89. We're going to get 3.21. So now the question is, how many items fall between those two values? Well, I go to my data set. 5 is included. 10 is included. 7 would fall into that thing. Would 12? Yep. Would 0? No. Would 20? No. Would 15? Yes. Would 22? No. Would 8 fall in? Yes. Would 2 fall in? No. So what we see is that there are 1, 2, 3, 4, 6 items that fall within one standard deviation of the mean. And sometimes the question will be asked, what percentage of items fall within one standard deviation of the mean? And the way you do that is you say, well, how many items are there? There are 6 items within. How many items are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what percentage of values fall within one standard deviation of the mean? And we would say that 60% of the values fall within one standard deviation of the mean. Now, I think I put a question like this in your quiz this week, so I just wanted to make sure we covered that. I do think that if you're unsure of how to use your calculator, rewatching this video would be helpful, although we've got some time left. So for those who would like a bit more practice or you would like to ask a question, just stay on the line. But Kia, if you could just put the link for this week's quiz in the chat. And if any students would like me to go over some calculator stuff again, please just let me know in the chat. Otherwise, you've done incredibly well. We've looked at today how to measure how spread out the data is, and we've covered the range, we've covered the interquartile range, and then we've also talked about the standard deviation. Please repeat the lower and upper bond. Okay. If we talk about a data set, you can find the mean and the standard deviation. So in this question, the mean was 10.1. The standard deviation for this data set was 6.89. Now, sometimes the question is asked, how many items fall within one standard deviation of the mean? Now, if you fall within one standard deviation, you can either be one standard deviation above 10.1, or you could be one standard deviation below it, going minus. So that's what I'm doing here. We're saying, look, 10.1 minus a standard deviation gives me 3.21, and 10.1 plus a standard deviation gives me 16.99. How many items from the set fall between there? And that's the ones that are yellow. There's 6 of them. And if we express that as a percentage, 6 out of 10 items are within that range. So we say 60% are within one standard deviation of the mean. How do we find 2 standard deviation? Oh, what does that mean? What does the difference mean between the mean and the standard deviation tell us? So what we normally do is the standard deviation tells us how far on average something is from the mean. But I don't think we need to go into more detail than saying, look, do you know how to connect, if the mean is the middle, the standard deviation talks about how far spread out something is. And so we talk that you can go above the mean or you can go below the mean. And to do that, that's one standard deviation within the mean covers both the left-hand side and the right-hand side, right? You can go from, on a number line, if you imagine 10.1, if you go up by one standard deviation, you would get 16.99. If you went down by one standard deviation, you would get 3.21. And if you fall within that range, that's within one standard deviation of the mean. Okay, Lorato, let's unmute you.
Hi, sir.
Hey, what can I do for you?
So I just wanted to ask, does it matter when you put it into a calculator, does it matter whether or not you put the numbers in chronological order?
No, order doesn't matter for standard deviation. Nope, it's wonderful.
Okay, thank you, sir.
And then Isamayeni, can there only be one standard deviation for a data set? So at school, we only deal with the population standard deviation. So there's something else called the sample one, which is the S, but we don't deal with that. There's only one standard deviation for a data set at school. Okay. Awesome. You guys